Hello everyone. We see the topic size dependent optical properties in nanomaterial. In nanomaterial, first we have what is nanomaterial? Material which structure features that at the nano scale. That is 200 nanometer. It exhibits unique physical and chemical properties distinct from bulk, size, shape, space area, govern behaviors, etc. Bridges between atoms or molecules and bulk materials regimines. Quantum mechanical effect demonstrate at nanoscales. First, next we see the size scale comparison. DNA strand similar to 2 nanometer, quantum dot 2 to 10 nanometer, gold nanoparticle 10 to 15 nanometer, virus 10 nanometer, human hair 70,000 nanometer. Next, quantum confinement effect. In OD confinement. And next, first next we see the quantum confinement effect. 0D confinement, 1D confinement, 2D confinement. In 0D we can see electron confined in all three dimensions: the descriptive energy levels, size, turbable, band gap. Example: scandium, indium, and scandium. Silicon. Next, 1D confinement. Confined in two-dimensional continuous along wires, axis, and anisotropic optical resonance. Example: zinc oxide nanorods, aluminum nanorods. Next, 2D confinement. Confined in one dimension. Exchange in plane mobility. Layer structure. Example: graphene monolayers. Next, we see surface plasmon resonance, SPR. Surface plasmon resonance is a collective oscillation of the conduction electrons at the nanoparticle surface in incident light. The resonance wavelength shifts dramatically with particle size, shape, and surrounding medium. Next, we see key mechanisms of this. Mind scattering, dielectric scattering, damming effects, shaping anastrophic. First, mind scattering. Small particles, that is less than 25 nanometer, absorbed large scattered lights. Dielectric function. Size dependent dielectric constant shifts resonance frequency. Damming effects. Surface collision increases with decreases size, that is peak broadening. Next, shape anastrophic. Nanorod shows 2 SPR, that is surface plasmon resonance modes, transverse and longitudinal. We can see here the table in size dependent SPR gold nanoplasmic. First, size 5 to 10, that is wavelength is similar to 514, color is orange red. 20 size 520 wavelength, color is red. 40 size 5 to 4 wavelength, deep red. 80 size 550 wavelength, orange. 100 plus size 570 plus wavelength, blue gray. Next, quantum dots. Sizes tunable photoluminescence. Quantum dots emits light whose wavelength is controlled by the size smaller. Emit blue or UV lights. Large ones emit red or IR, purely due to quantum confidence. First, UV or violet, that is similar to 2 nanometer, 400 nanometer. Next, blue, that is 3 nanometer for 450 nanometer. Crayon, that is 4 nanometer size, 590 is wavelength. Next, green, 5 nanometer size and 530 wavelength. Next, 6 yellow. Yellow is 6 nanometer size, 570 nanometer is wavelength. Next, orange, 7 nanometer is size and 620 is nanometer. Next, red. Red is 8 nanometer and 680 nanometer is wavelength. We can see here the increasing order of size and wavelength. Next, my theory and size dependent optical absorption. My theory overview. Extraction solution. Regenerative analytic solution of Maxwell's equation for spherical practices in the homogeneous medium. Next, extend cross section. C extend equal to C apps plus C scan. That is sum of absorption and scattering cross section depends critical on the practical radius. Next, small particles. Absorption dominance. C absorption in directly proportional to R cube. That is color dependent by absorption wavelength. Large particle. Scattering depends upon C scattering directly proportional to R power 6. That is multiple resonance modes appears. Quasi-static limits. For particles that wavelength polarity is directly proportional to phorolytic condition governs resonance. Next, type of nanometric and its properties. Particle nanometry. AU, AG, PT, CU nanoparticle size tubable SPR is 400 to 1200 nanometer. Next, AU is red blue shifting. 15 to 150 nanometer strong SCRS signal exchange. Next, LSPR is for biosensing. Next, semiconductors. QD, CDSC, INP, zinc sulfate and PBS. Band gap 1 to 4 EV. High quality yield greater than 90%. Narrow emission line width used in LED solar. Next, carbon nanomaterial. Carbon dots, graphene QD. Photoluminescence varies with size. Functionalization dependent emission. Non-toxic biocapable. And next, upconsising fluorescence. Next, metal oxides. Wide band gap, UV absorption exchange, photocatalyst exchange uses in sunscreen and sensors. Next, fabrication and optical characteristics techniques. Synthesis method. Collining synthesis, hot injuries, nuclearization growth control. Paradises QR size distribution. Chemical vapor dependent. Thin films and narrow wires growth with atomic levels thickening control. Sol gel process. Metal oxides hydrolysis or condensation. Easy size tuning. Ball milling top down. Mechanical size reduction, less precise but scatterable. Lithography. Electron beam lithography for well-defined nanostructure arrays. Next, characteristics tools. UV visible spectroscopy. Measuring optical absorption spectra. Spectra reveals SPR position. Next, luminescence. Emission spectra quantize QR size distribution and quantum yield. Thank you.